Okay, so thank you guys so much for coming to today's workshop. In case you didn't see already, today we're going to be talking about programming and particularly intro to Python. Python is a fairly simple programming language to get into, and we could use Python to show different programming applications in cybersecurity. So at the end of the workshop, I will be going over a few demos of just something I was able to snatch online that kind of represent that in a very good way. And that'll be after our demo, which we'll be able to actually practice coding in Python as well. So, oops. Okay, so couple things announcements to talk about. Next week we'll be having our guest speaker Alessandra Gomez. She works at CrowdStrike and she'll be talking about her experience at CrowdStrike, but also her journey into cybersecurity as well, similar to this Tuesday. And also next week's meeting will most likely be virtual as well, due to room issues. So you guys could just join the Zoom for the meeting on Tuesday. And same thing with the Friday as well. Well, next Friday we'll be having a intro to networks, web, and cloud workshop. So hopefully I could see you there. And last two things I want to talk about is our Converge conference. So each year we try to go to a conference called Converge, which is a conference for cybersecurity held by Josh Chin, who's actually one of the professors here. He's like the main coordinator of that, and we are able to get specific discounts for tickets to that conference. And it's a pretty cool conference. I've been there once, and there's a lot of cool professional industry professionals who talk and also provide activities. And so we have an interest form on Discord, which you could fill out. We will be providing a free tickets to paid fast members. So if you're interested, you could get more information on Discord and fill out the form there as well. And we'll try and figure out carpooling situations. I think there's some information in that for the form as well, but hopefully we'll get that sorted in the near future. Last but not least, we're gonna I'm gonna have Matt talk about his digital forensics group. So Matt, you could take it away from here.
Okay, so for those of you on my Digital Forensics Discord, I think you already know that there's going to be a meeting happening this Sunday at 7 p.m. But I just wanted to tell all of the general people here at the meeting that I'm going to be having that meeting at 7 p.m. And what we will cover this Sunday at 7 p.m. on Discord, on the server itself for the Digital Forensics team, is we're going to go to the intro of digital forensics and what it is, why we need to be good at it, and what are some of the tools that we can use to do it. So if you guys are not part of the server and any of this sounds interesting to you, I am going to put in a link to the server in the chat so that you can come and check it out.
All right, Matt, that sounds good. Thank you so much. And again, if you're interested, you could check out the Discord link in the chat at Matt. All right, so just to go over the objectives for today, we're going to quickly install Python and possibly VS Code. So I don't think we need to install VS Code. VS Code is sort of just an IDE that allows us to program in a more simpler like editor style. So it's kind of like a UI to it. But I think for today, we just need to install Python so you guys could follow along with the activities that we have later. We're going to also talk about the basics of computers and programs, their relationship, how programs work within like the hardware. We're going to talk about different types of programming, how they could relate and differ, and then we're going to actually go into our basics with Python. All right, so real quick, we're going to take this time to actually go ahead and download Python. To do that, you're going to go to python.org/downloads and then download Python for your respective operating system. If you're interested, you could also download VS Code, but for the examples we have today, we could just either use Notepad and also the idle Python program, which allows us to use a sort of Python shell to interact with it as well. So we're gonna take like around 30 minutes to do that. And then while it loads, we'll go over like the other notes while we wait. Just to show you what that might look like. Go to python.downloads. There's a button right here for Windows. I myself am using Python 3.11, but Python 3.12 should be just as fine. And below that, you also have the different versions of Python for different applications here. So I already pre-downloaded, so I'm not gonna go through that step. But if anyone is having trouble during that process, let me know and I'll try to help you out the best I can. Everyone doing good so far? It's downloading. All right. So while that's happening, I think I'm just gonna quickly try and go through the notes so that we could go to the actual examples. So really dumbing down the ideas of computers and programs. The main goal of computers is to really store information and also execute different tasks. We'll go into it a bit more, but computers can really be summed to an input and an output. The computer takes something in, whether it's a user interface, keyboard, mouse, etc., and does a whole bunch of operations on that based on what the user did and gives out an output. These diagrams here are really complicated, but it goes to show that despite having a whole bunch of components that each do their own specific task on the hardware level, when we're I guess using software or writing programs, the main concepts that we're going to be dealing with is input and output. What are we giving the computer and what is it spitting out, basically? I think we'll do this one first. So simple example is the print statement that we'll have in Python. We'll go over what that actually looks like. But if we have like a function in this case, or we want a command that we give it, such as print hello, there's a whole bunch of inner logic that happens in the program. And within the input we give it, which is hello, there's a specific output. And so programs are legit just mostly just that. And it could be more complex than just printing the word hello, but ultimately that idea stays relatively consistent. In a more specific example, there's obviously things that happen under the hood in terms of programming. There's stuff that's already been programmed through like Python libraries and just the Python interpreters / compilers, which break down the Python code into digestible hardware level languages, which we'll talk more in the other slides. But when we're actually programming with Python, it's gonna look more like logical implementations with Python. So we determine in the program what we want to do and the different quote rule sets or the instructions that we want either a function or a class or a file to have, as well as scripts. So okay. Okay. I think Matt posted some information about Mac users. So if you have some trouble, you could check that out. And if you're having trouble installing, feel free to interrupt me and ask. We want to make sure we have that installed before we move on. Okay, so going to program flow, one of the biggest things that confused me when I was learning about programming is how exactly languages like Python are really processed on the computer. And personally, I put this slide here to help visualize how everything really exists on the computer. Especially when it comes to high level stuff, it seems so like abstract and magical that I think this without this conceptualization, there might be some gaps in confusion. So to really summarize, we have basic circuits in electronics and gates that potentially do different logic things and are able to store information on a fundamental level. And from there, we actually have machine code, which is just ones and zeros that we're able to feed into a computer made with, electronics to be able to process different commands, such as adding and subtracting numbers, storing uh, data on registers and whatnot. And from there, we have our first low-level code, which is usually in assembly. Assembly is also a programming language that directly translates to machine code based on what type of hardware you're running and what operating system you have. And so from low-level code, we have high-level code, which basically compiles into low-level code and is able to do all those different things. If you're more interested in what that might actually look like, I posted a whole bunch of YouTube videos that provide really interesting analysis on each sub-level. But you can see here on the left, we have like the actual tangible hardware material. And as you keep going, you get more to the abstract programs and the languages that we're able to do essentially because of each step. And there's honestly a million things that happen in between like electricity, for example, and like high-level code. But overall, this is a relatively good structure for what that looks like. To talk a bit more about what goes on in between, from high-level code to low-level code, you have a compiler that breaks down high-level code into simple instructions in assembly. And from there, we have an assembler that's able to take the assembly code and turn it into machine code. And once you have machine code, you can simply process it onto a hardware system. And more links to that as well if you're interested in looking at what that might look like. Okay, so now that we have a good general idea of programming, I want to talk about its different categories or some possible categories that we might be able to see programming in the real world. So first, we have application domains. Programming is used for a lot of different purposes. And depending on that purpose, you're going to see it used and written in different styles and ways. So for application, we have programming for web development, so websites, mobile development, which is apps and anything that you see on the phone, game development, which is development in video games, which could also include either web, mobile, or just like on the computer itself. We also have data science and machine learning, so specific implementations of programming that allows us to analyze different tables and data sets and machine learning to be able to predict based on certain data sets that we give it. And finally, we also have network programming. To talk about the paradigm, there's a lot of different ideologies when it comes to programming with so many of the high-level languages that we saw earlier. Although they have some similar characteristics that we'll talk about, they also have their unique characteristics that make them different from one another. And some of those differences could be pointed straight towards what kind of paradigm they use. If the different paradigms examples could be either procedural programming, object-oriented programming, and functional programming. We won't go too much into the paradigms, but it's good to be aware that not all programs or languages are going to look the same and the approaches are going to be different. Finally, we also have purpose. As you can see, application is in there, which kind of refers to the application domains. And so it's in a way a bit more similar, but for purpose, I like to think of it more on the physical or how it manifests in the real world. So we could either have some systems, so a computer system, maybe some server racks, anything we're trying to store data, not necessarily focused on the UI side of things. Then we have application, which is more based towards common use programming and how programming is shown in common ways. And finally, there's embedded, which refers to the more smaller computers used in either in many products, either everyday products that are sold in bulk, basically, or systems that have one purpose, such as like a washing machine or like a watch. Smaller computers that still use programming, but because of its physical restraints, make it a little bit more different. So, all right. Quickly summarizing over application domain. One thing I do want to say in terms of terminology is, let's see. So language versus framework. So I want to say that Python, Java, JavaScript, these are all languages. The syntax is different, and depending on what language you use, you could fundamentally do some different things. Frameworks are ultimately built upon languages, and different frameworks provide different purposes within the application domain. And these frameworks they could be based on one or more specific languages, but the framework itself is not necessarily a language. It's more or less like a prepackaged use built upon whatever language you decide. Quick examples is that Python is a language, but if we're using Python for data science and machine learning, we might use something called PyTorch or TensorFlow, which is a machine learning framework built in Python. We also might use network, web frameworks such as Django or Flask, which are also built in Python, but they function very differently from TensorFlow or PyTorch, despite both being built in the same language. And there's some other things here that show a whole bunch of frameworks. There's a lot of companies and organizations that go into developing different tools and frameworks for users to use. But some of these are based upon the same languages, either in the same domain or not in the same domain. So I just want to make it clear that there's a difference between the two. And with whatever framework is used, there is sort of like a quote competitive nature to it. Just because a framework is created doesn't mean it's going to be popular. So a lot of the frameworks you see here, they're constantly being improved and adapted to meet customer demands. So ultimately, these frameworks are essentially products themselves as well. So that is one way to think about frameworks. All right, so actually, we're gonna go and skip that. Okay, so I think it's okay to go straight into the activity. So we're gonna be coding in Python, and we're gonna be, I think, hopefully everyone installed Python already on their computers, and I think everyone on Zoom should have Python installed, hopefully. We're gonna do some simple input output just to see what it looks like and how we could actually run a program or run code in Python on the computers. And we're gonna be doing essentially a crash course for programming. And so I don't expect everyone to completely master everything I teach, especially if you've never programmed before, but it should provide a very broad overview of what's in store for programming. And I think the biggest tool a programmer could have is, quite frankly, Google. When you are programming, you get stuck on something you've never seen, you put it into Google, see what you get, and see if anyone else had the same issue you had, and try and do what you can to really fix and solve your problems. And with that, you'll most likely go to Stack Overflow, which is a website for debugging. And YouTube could also help, but for YouTube, I generally like to see like broad overviews of concepts. So that usually helps me out. Okay. All right, so I hope everyone has Python installed. To check if you do, and we might go on a hurdle with this, but let's see. So when you install Python, it should be installed globally, which is a term that means you could access it from anywhere in your terminal. So right now, if I open up my command prompt or whatever, I think terminal that you have on your OS, I'm just in my user path right now. And if I type in Python dash dash version, I get Python 3.11. This shows me that Python is installed on my computer, and it is a good way to check if you have it installed. Um, if you did install it and it doesn't show up, we may need to add it onto our environment path, which I could try and help out with. So, is everyone able to see Python, the version number on their terminals? You got one here. Can you see better? Okay. All right. Having trouble? Okay. That's good. So gonna go help. I hopefully this will work, but so sometimes if you type in Python version, it will say that the command isn't found, which means it's not on our environment path. So if we go to our search bar and we search up environment, for Windows at least, you have edit system environment variables as an option. Oh, okay. Yeah, for sure. Maybe Python 3 also works for some folks. Oh, yeah. Maybe that's what you have to do because I think it looks like I have both Python 3 and regular Python. So I think when because I installed it a long time ago, so it might be misconfigured. Have you tried Python 3? No? Okay. We might have to troubleshoot this, but so for the environment variables, if you click on environment, and if you go to path, this I have a whole bunch of paths here, but we should be able to see the Python path here, and putting that I think is what allows it to show up. You have to put in your local path, so wherever you have Python installed, you have to put that path in your environment variable. And so you try go ahead and find that, put it there and see if it works. If not, I'm not exactly sure. You could try Googling it as well. But just something we have to do. So yo. Yeah, so we just installed Python and we're just gonna go over some programming basics. And you're gonna be able to follow along with what I do you have Python installed already? Okay, then you should be good to go. Does anyone on Zoom have any questions? Oh no, why can't you see my screen? Okay, let me reshare that. Sorry about that. All right, hopefully you could see it now. All right, sounds good. Sorry about that. Again, if you installed Python, you should be able to check its version number by typing Python or Python 3 and dash dash version. They should both work if you install it, but I'm not too sure. Okay. Yeah, we'll probably be using Python 3. most likely. Right. Was it working now or is something? Oh, okay. Yeah, it might be different, but for sure. Yeah. And I'll say this one last time. If you get any error or you have like it spits out some kind of like error message, copy paste it into Google, you might find something helpful. So it's always helped me. All right, so I'm gonna continue onward, assuming that we have it working. So if we search up, I think that it should automatically be installed. But if we search up idle Python, we're able to get a Python shell for us to be able to use. And this right here is very helpful for running Python code very quickly. Are we able to get to the shell? Yes. Okay. Should be called idle shell. And if it doesn't show up, we'll try and find it. But I believe it auto-installed when I installed Python. So let me know if you have any questions or if something isn't showing up. All right, I think we're all good. So one thing I do want to mention is compiled versus interpreted. So in our last one of the previous slides here, I talked about how the compiler is able to compile high-level code into low-level code. Usually this is done through just done through compiling the entire file with our program. Python, however, is referred to instead of compiled, it is interpreted, which means that instead of having every single file be compiled once, it is actually able to compile, it actually compiles each line one at a time. So with what this shell allows to do, it allows us to run Python code one line at a time. So our first command that we're gonna do is just the print statement here. If you guys haven't had a CS class or you have never done programming before, a print statement allows us to give it a certain string or a certain list of characters, and it's able to spit that out for us in the console or terminal or whatever output you're given. So if I do print parenthesis and in quotation marks, hello world, exclamation mark. If we press enter, we actually get the string printed out on the screen. So we'll be talking more about strings, which is what we call a list of characters or just words. We'll be talking about that a little bit more later, but just know that if we're trying to print a sentence or words, we want it in quotation marks. Or even I think single commas work as well. So print yeah, that should also be the same thing for Python. All right, so one more thing I want to show you. So that is one way we could execute Python code. Another way we could do it is just run a Python file. So let's see. If I go to my file explorer, all right, so I'm in my file explorer right now, and I'm going to create a new file and let's call it hi.py. So each Python file has the extension .py. So if you name something .py, the computer knows that it's going to be a Python file. So we're going to go ahead and make that. That's fine. So it turns into a Python file. You see a little Python icon in the bottom there as well. So I'm just gonna open this with Notepad because it's easy. Actually, let's see. I could edit in Notepad. This is just to get the idea across. So if we're using Linux or different operating system, we talked about text editors in our last workshop. But we would usually use a text editor to write this code, but because we're not really focusing on that, I'm just going to use Notepad as an example. So on Notepad, I could actually print a whole bunch of lines, as many as I want. And just as an example, I'm gonna just copy paste a whole bunch of print statements here. So here I have just multiple lines of Python code, right? And we'll get to more advanced things in a bit, but we just have a whole bunch of print statements for now. We're gonna go ahead and save that file. And if we go to our terminal, I think we could also do it maybe in our shell, but just to show how we could run that file. If we go to the same directory where we made that file, which for me is going to be coding/fast. Let's see. Why is it being weird? Is it desktop? Okay. 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 So I can't do that. So we're on the same directory where I made that file. If I run python py.py, it goes ahead and prints each of the lines that we had in the file. And so show again, here's the program that we had, and here's the output that we executed. So programming, this might be a bit obvious. So when we're programming in this sense, we're choosing the logic and the structure of the program here, and we're able to execute that code through our console, and it's able to give us a result. Okay, so with that, we're gonna move on. I'll be using both the IDE and the shell for examples, but we're gonna be going into programming basics, which is based around syntax and operations. So first, we're gonna be talking about variables and data types, how exactly we can store information and data in Python. We're gonna be then going over control structures, which allows it tells us which code is able to run and which code shouldn't run, and we're able to control sort of like the if-else statements, if you guys heard that before. Then we're going to be talking about functions and procedures, which is sets of Python code that we could group together and call whenever we need to. After that, we'll quickly go over classes, and then data structures and algorithms as just sort of like a topic thing that I'm going to discuss. We're going to then talk about file input output and how Python can interact with more system commands. We're going to talk about error handling, just the basic ideas of that and how it's really helpful when we're programming. We're going to talk about libraries and frameworks, show how that integrates with Python. And finally, if we have time, I do want to talk about version control, because this is something that shows up a lot in not just in programming, but also partially in cybersecurity as well. Okay. So to kind of jump straight into it. So data types. So data types define the type of data a variable can hold. There's specific types of data types in programming that we're able to declare. The first one is integers. Integers are just going to be whole numbers, 0, 1, 2, 3, 4, and negative numbers as well. If we're thinking about maybe like the decimal number, then that would be stored in something called a floating point number or a double. Next data type we have are characters, which is just a single letter. You can think about it that way. If you're familiar with ASCII, characters are usually represented in the ASCII format, which is a number letter conversion that was made to unify symbols and how they're represented. And finally, all right, the last two we have strings, which is you could think about it as a sequence of characters. So it just uses an array or basically a string of characters. So it's called a string because of that. And finally, we have something called Booleans, or Boolean for short, or bool for short, which could either just be true or false. This also interprets as 0 or 1, 0 for false, 1 for true. So they relate to integers in that. Thankfully, in Python, when we're declaring a variable, which is what allows us to actually store information, we actually don't have to declare what data type we're using. We're doing different programming languages like C or Java. We would actually have to indicate what data type we are storing into our variable. So in this example on the top right here, we have age equals 35. Get rid of that semicolon. So age equals 25. Here we have the variable name, which is age, and the value, which is 35. So a quick example I could show is if we go to our notepad, if we declare the variable age and do equals to 50, for example, and if we go ahead and print out age, so we had the print statement earlier with the string, but this time we're actually gonna go ahead and put in the age. If we save and run that, we should be able to get 50 right there. So the variable age is able to hold different values depending on what we give it. We could give it any data type that we mentioned here, and it is able to store that for as long as the program runs. Okay. When I was making these slides, I kind of put in Java syntax, so you might see semicolons, but in Python, at the end of the lines, you don't have to put anything. In other languages, you might be required to put a semicolon to indicate the end of the line. So thankfully, we don't have to do that here. And with that, we could also do operations with our variables. So on the bottom left here, we have age is equal to 1, and then age equals age minus 2. So if you have done programming before, this might be pretty obvious, but if you haven't, this might be a little confusing. How can age be equal to age equal or age but 2 of itself? When we use the equal sign in programming, that refers to assigning a value. So we have age is equal to 35. That means age is now integer 35. And same thing can go in this case where we're changing the value of age into what it was minus 2. So we know age is 1, so we're gonna actually get the value of age and then subtract it by 2, which is -1, which means age is now equal to -1. And yeah, and if you want to just code, you could just do it on your computer as well, and then you'll be able to see what value the variable is by using. There's also some shortcuts as well. This actually doesn't exist in Python, but if we do age plus equals 4, we're doing the same thing as the thing above, but we're able to not reference the thing twice. So if age is -1 after this, plus 4 is going to be 3. So age is now equal to 3. We basically increment it up 4 times, and we could do it for both plus and minus as well. And I think we could do it for multiplication and division. So we could do all 4 operations within the variables that we have here. So just to do an example, we have age is equal to 20, age age is equal to age plus, let's do -5 for fun, and then we'll print age. Run that. It's going to give us 15. If we do age is 22.6 and we do age plus equals 5.27, I don't know. If we go ahead and print that, that's going to give us 28.3. If we also, the cool thing with Python, because we don't have to declare the data type, we could also do things like adding a double or a decimal value to an integer, and it would still work. If you do this with other programs, the program might crash, so it really depends. But Python is not very restrictive with that, so it's able to still do the math for us. Okay. You could also do, let's say, multiply equals, which is just equal to age, I guess equals age times 5. So if we run that, that will probably, that will give us 22.6 times 5, which is equal to 113. One thing I actually did forget to talk about is commenting. So in our program, we sometimes want to be able to write comments for ourselves, indicating what something does or how something works. In Python, we're able to do that by putting a hashtag or a pound sign in front of whatever thing we write. So if we do a hashtag here, this line gets pretty much ignored and is only used for reading. If you're using an IDE, it'll like show up as like faded in the font, but since we're using Notepad, it doesn't really do that. So yeah. Okay. I think we could move on from there. Does anyone have any questions so far about the data types and variables? Okay. Pretty good. So next we're going to talk about control structures. So conditionals or control structures allows us to run code blocks based on certain conditions. And we could also, conditionals itself usually are in the form of if-else statements. If condition A, if 5 is less than 3 or is less than a certain variable, then we're going to run line A. If not or else, we're going to run a different line. So here we have a pretty unique example where if age is greater than 20, print old, or else if variable name, print variable name is true. This might be a little confusing and it's kind of a bad example. I should have put something else like age is greater than whatever, but if we go ahead and modify this just a little bit to show you what conditionals are. Let's do age is greater than 40, do very old, and else not old. And we could set age to 30. Actually, it's very bad code. Let's just change some stuff up real quick. All right, so a simple if-else function right here. We have age is equal to 30 and two conditionals, if and then else. So you can probably tell what will happen based off of the code we've written. But if we go ahead and run that, we're going to get old because age is 30. And because 30 isn't less than 20, it's going to skip the line. This is pretty young, and it's going to go to the else statement for print old. And then as you change it around, if you do a lower number, oh, why is it doing that? Oh, you didn't save it. And if we set it at 16, that's gonna go to our first condition and it's gonna be true. So it's gonna go down to that line there. So what actually kind of happens too is when we talked about Booleans and how it could be true or false, the statement age less than 20 is a false statement. Or it could be a true or false statement depending on what the value of age is. And so we could also just input true here. So if true, print young, which means that this will always print young and it'll always do that line. Oh no, it's capitalized. It's case sensitive. So it'll go ahead and print young. Same thing with false. So you could also do else if, which is a similar to else, but it will go to the next one if the conditional before it wasn't true, and then do the same thing with a new condition. And else is just kind of the default thing that we go to. So yeah, I guess I'll do that. In Python, we use indentation to declare like code blocks. Some other programs use curly braces or brackets. And so to distinguish which line is in the conditional, we use indents to basically separate that. If we don't indent it, then it usually prints something false. So it's got to be able to read indents one way or another. Okay, so that's just a very basic rundown of conditions. Next, we're going to talk about loops. Loops are very similar in that they're also given a condition, but they're able to repeat for multiple times. So at the bottom, we have a while loop here. While variable name is false, print loop, and then you could also do some optional things with that. So this might be a little bit fast, but let me see if I could create something for us to see. Then so here we have a simple for loop. Index is equal to 0, and while index is less than 10, print index. This will actually this will continue to run because we're not changing the value of index. It's going to constantly say 0. And because 0 is always less than 10, it's just going to keep printing index. Because we don't really want that, at the end, we're going to do index plus equals 1 to add it each time. And so if we go ahead and do that, let me run it, you should get values 0 to 9 because here index, when index is 10, in 10 isn't less than 10. So it's not going to actually run the code. And if we do less than or equal to, it's actually it will go ahead and print 10 as well. And I should have talked about conditions or comparative values, but we have less than or greater than, and we also have the less than or equal to or greater than or equal to. And we also have equals equals. I want to talk about equals equals real quick because sometimes they get confused with regular equals. When we have the equal sign for declaring a variable, we have just a single equal sign. And so we can't really use it again for condition or checking conditions. So we have double equals here, which basically asks, hey, is the left value the same as the right value? So the code here will actually, won't run here, but in this case, it will ask if the two values are the same. If we put I guess if we put not here, and in Python, the parentheses are optional, so I'm going to actually remove them. But if we have while not index equals 10, it will the conditional becomes the reverse of index equals 10. So anything that's not 10. And if I did this right, it should go ahead and do the same thing. Yeah, so 0 through 9. Let's see. There's some stuff that I'm skipping on because I'm kind of going all over the place. So I apologize. For in regular like math equations for in just like whatever code that we have, if we have parentheses, this is not really a great example, but if we have parentheses within like an equation, it's obviously going to do the equations or the command in the parentheses first. So when we have conditionals too, sometimes we put parentheses to indicate the conditional. On some languages, you need to have that. In Python, it's not really required, but just wanted to let you guys know. All right, so any questions on that so far? Okay. One more thing I want to say is that we can combine conditionals as well. And I'm running a little bit fast here, but just an example. And so let's say I have Boolean value, and Boolean value is equal to false, right? So in our condition now, we have index is equal to 10 and Boolean value. So with this and symbol here, this allows us to create multiple conditions. Actually, I didn't update this. It should just be and in Python. So this should just be and an or. So and an or, those keywords allow us to add multiple conditions on the same line. So if we go ahead and run this code, that's actually not going to print anything because Boolean value is false. And because, oh, sorry, should do this one. Should give you the same thing, but because index is, even though index is less than or equal to 10, because Boolean value is false, it's not going to run the condition because both conditions are true. If, however, we change Boolean value to true, it's going to go ahead and satisfy both conditions. If I did it right. Yep. And then it's going to go ahead and execute that line. So it's also how you could add multiple things at the same time. All right, next we're going to be talking about functions. So as I said before, functions allow us to create different code blocks that we could call on. So it reduces the repetitivity of code. It usually has a format of a declaration and a function, or a declaration and a definition. So in this case, we have an add function called def add. So add is the function name, and we're able to put in different what we call argument names to show what our input is for those functions. So if we just do a quick example. So we have add parentheses a comma b. Total equals a plus b. So here we create a variable called total, and it includes the sum of a and b, and we return total. So the return statement here for functions, we want to usually return some type of output. The output could be void or empty, but in this case, for our add function, we want to be able to return the total. So the return keyword is used to do that. And so if I have a equals, or let's try first equals 4, second equals 5. These are just some two variables that I made. If I do add parenthesis first and second, and let's set that to the value sum. If we go ahead and print sum, we should be able to see that the function went through. And if what's going on seems complicated, yeah, that's completely okay. Usually we would have you would spend more time on learning the things that we learned previously. But again, this is just the crash course, so I'm doing my best to kind of move things along. So here, when we call add first and second, it goes ahead and see what the definition or what the code block for the add function is. And it goes ahead and executes that. And once it returns the total, or it says return, it goes back to where the function was called here, and then it's able to be stored in the sum variable. Yeah, and because it has a return statement with a value, usually we want to associate that to a variable so that it can be stored. Okay. So there's a lot of reasons or features for functions that make them really useful. This could include modularity, which is breaking things into different sections. If we wanted to add or do a function multiple times, it'd be really tedious to write down each of that functionality to every single time it's used. We want to just call a function for that and have the function be defined just once. It could also help with abstraction and allows us to not deal with specific details. If we're using a library that has some pre-made functions, we don't need to worry about how that's implemented. There's also code reusability similar to modularity. There's also readability and maintainability. So it's just easier to read and understand what the code's doing when you just write functions. And it also helps with testing and debugging because you're able to figure out where code is doing the wrong things or where it's messing up and whatnot. Okay. Let's see. There's some other concepts here that you guys could look at afterwards. I won't go too into detail because I realize that might be a bit more advanced, but if you Google or do some research on these other topics, these are some more common things that relate to functions and how they work. And so if you're interested in learning more about programming, I highly suggest checking that out. Okay. So we have a little bit of time. I'm almost running out of battery on my laptop, so I'll try to speed this up. I think from here on out, I will be mostly talking about just how it works. So I'm just going over the slides because I'm not sure if I have enough battery to show examples, but we're going to go on to classes now. So classes are part of the object-oriented programming paradigm. And a class is basically a blueprint that allows you to create objects, which are called instances. Classes define different attributes and methods and functions that are created that objects which are made based off of classes are able to use. So here we have a really simple class called dog. The dog has a function called bark here, and it's just a simple print statement that says wolf. So that's the function or definition that we saw earlier. And this middle section here is something called a constructor, which is a function that's called when the object is created from the class. So in the specific format here is not super specific. The syntax here isn't what we're going to be talking about, but what's important here is that we have self.name and self.age. So these are the two variable names that are associated with the class. And from there, we're actually allowed to be set to name and age, which, not to be confused with the variable name, is actually the argument name that's in the parentheses there. So if we do dog parenthesis, I guess what's the name of the dog, Clifford, and 20, then we're able to create a dog object that has variables name and age equal to Clifford and 20 respectively. So there's also some other neat tricks such as inheritance, encapsulation, and polymorphism that are ideas extended from classes, but classes allow us to really organize structure and different features within a set of objects or classes. So yeah. All right. Next is data structures algorithm. This isn't really necessary, but I just wanted to talk about it because it's important when it comes to the world of programming. So data structures are collections of different elements of the same data type. So each variable, when we give it a value, we're only allowed to set it to one element. So we could only do like variable, or we can only do like age is equal to 35. We can't make it age is equal to 35 and 40. But the closest thing we kind of have to that are arrays, which is sort of like it's a data structure that allows multiple values to be stored. So this isn't exactly the right syntax, I don't think. Yeah, we don't need the data type in parentheses there, but if we do array is equal to bracket 1 comma 2 comma 3 comma 4 bracket, we essentially created an integer array. In Python, arrays could hold any data type, so this is just the integers. But using arrays, we're able to store sort of like a container of different data values that we could say. And depending on the data structures that we use, we're able to run algorithms that are able that find different solutions to what we're looking for. If we had a really big array, and you wanted to find like the maximum number in the array, we would run different algorithms to be able to get that. And so this is a bit more complex and is not really necessary, but there's also a world of programming that deals with developing algorithms and figuring out what the best algorithms are for specific situations. Yeah, so just to answer your question, the shell, sorry, I didn't see this till now. So the shell runs one line at a time, and we're actually able to execute Python code and have it run as it happens. So if I do print, like a print statement here, and we put in a string hello, then once we click enter, we'll receive hello. With compared to the file, which we do it all at once. I think we could also store variables in the shell. So if I do 36 and do print age, it actually prints 36 as well. So it remembers variables too, but the shell is just used for very simple things most of the time. Okay. So Python has a whole bunch of pre-existing functions too. If we actually go ahead and run this on our shell, if we create an array with, where's the shell? These specific values. So array equals 2, 1, 4, 3, separated by commas. If we run array.sort, it should, or let's do array2 equals sort. Array2 equals sort. Dot sort is a pre-made function that sorts values in an array. So if I go ahead and run that and print the result, that's not right. That's really weird. Let's try just array that sort. That's weird. Okay, so I messed it up. So the dot sort function actually changes the values in the array. So we had the array equal to 2, 1, 4, 3. After running dot sort on it, we get 1, 2, 3. So sorts it in order from least to greatest. And stuff like that. The sort method itself, or function itself, uses a whole bunch of algorithms to quickly sort the values, but the sort function uses algorithms to be able to sort values in a fast way. And is an example of how algorithms is used in the programming sense. Next, we'll be talking really quickly about file input output. So input output basically refers to reading and writing to files, and Python has some functionalities for that. So this is just a quick example of what that might look like with open file.txt, and then the character R, which represents read, as file. So when we do as file, file is the name of the variable that allows us to interact with the file.txt that we open. If we do content equals file.read, the read function returns the contents of a file, and we store that in the variable name content, and then we could go ahead and print that out. Yeah. So you guys could try that on your own as well. And error handling is just the idea that we have some special keywords called try and except, or sometimes catch. We could run certain pieces of code in the try block, and if something goes bad, if we get an error, we could be able to catch that in the except section here. So we have result is equal to 10 divided by 0. This will most likely give you a divide by 0 error. And so you actually can't divide by 0 in programs. Most likely your programs will crash. When this happens, the program catches that an error is thrown in this line, and then it goes to this line here and execute whatever you want. So if you don't want your code to crash, try catch or try except formats are going to be your best friend. And so next we're going to talk about libraries. This is going to be really important because most of the code that we write are based off of code that other people have written or code that has already been written. And so libraries are collections of functions and procedures used to perform common tasks, which helps speeds up the development process. So an example in Python, we have something called pip, which is the Python installation. No, well, pip is the package manager for Python and allows us to import and install different packages that other people have written. So we have here pip install numpy. I'm just gonna use the terminal as an example here. So ignore all of this for now. If we run, let me just set up this real quick. Okay. So if I do pip install numpy, it's gonna go ahead and go through a process of getting the NumPy library and installing it onto the system. You don't have to worry about the specifics of what's going on, but if you're using specific libraries that you want, that's how you would do it. This is just my terminal here. I'm doing it through VS Code, which is like my code editor. So, okay. I'll talk about, I'll continue going. I have to really use the restroom, so we'll go ahead and take a quick time. I'll be right back. Okay, sorry about that. Okay, so same way with installing, you could also uninstall programs. So pip install numpy. Let's say we don't want it anymore. It'll go ahead and remove that library from our code base. All right, there we go. So that's the basic idea of libraries and how they might work. Depending on what program or what language you're using, the process for installing packages would look different, but usually you're able to find it online and see the command for how to do that. Okay. No. All right, so really want to quickly talk about Git. So version control is not necessarily programming, but is sort of a bigger idea outside of it. And I just wanted to put it here because it's not something that's talked about a lot, but very important. So let's say you were writing code on one computer and someone else was writing code on another computer, and you guys wanted to quote share the code or that assignment or whatever. Version control is the idea of how we're able to support different versions of a program or code without having things be deleted or having more structure to how that works. Um, in that sense, Git is a very popular type of version control, Git, Git. And so here you kind of have, in this bottom picture, you have different branches, we'll call it, that are associated with different colors. So you might have the main file or code stored somewhere, and you're able to make a branch off of it, unlike the purple line here. So you have a version that's just the same, and through the purple line, you're able to make any changes that you want on, I guess, like a different computer. You would, I guess, for terminology, you would pull the branch and then make any commits to it, which are any like additional changes, and then we'll push it back onto the main branch. Now, the main branch here, the blue one, will have the changes of the purple. So if two people simultaneously um, work on the same branch, it could lead to issues because when I'm working on code on my computer, another computer isn't able to know what's being changed unless they're directly connected. And so branches help us distinguish who writes what, who is able to, sorry, who writes changes and when they write it, and being able to figure out how to not like overlap what they're working on and yeah, whatnot. That's just a very basic description. It takes a while to actually go over what that looks like, but um, understand that that version control is the idea of different people sharing code from the same repository or code base. All right, so there's a lot of different applications of programming in cybersecurity. And I'll be going over some examples with Python, some things I was able to scrap up. If you're interested in programming or want to do more things related to programming, such as reverse engineering, malware development, or development within cybersecurity programs like firewalls, um, and I think what's called intrusion detection systems. Programming is very relevant in those fields as well. So I'm gonna go quickly over my demo. I have, I think, around four-ish, four working programs here that I was able to use based off of some YouTube videos that I found. So this right here is Python code that I sort of modified to be repetitive. It's called Python cipher, and it just does Caesar cipher on a specific string. Caesar cipher is a cipher that basically takes the alphabet and rotates it into different positions. And so it's able to encrypt specific messages. And this Python code is able to manually do it for us. So if I go and run Python dash cipher.py, we have our terminal here, and it says enter key 1 through 26, and it's kind of just waiting there. I didn't include this, but we could use something called input, which is similar to, I guess, print, but instead of printing something, it's going to wait for a user to give it data. So it's asking for 1 through 26. So I'm going to give it 24. And when I click that, it's going to go on to the next, it's going to continue on with the program. So input is just a way for the program to get information from the user. And it's going to ask encrypt or decrypt. I would want to say encrypt. And so I programmed it so you have to enter E. So it's going to ask me for the data. I'm just going to put hello world. And it's gonna give me the encrypted word for that, which is like a whole bunch of jumbled up letters. So now what I can do with this program, for example, is do decrypt, and then I'm actually just gonna type in the same thing that it gave me. And because it's using the same key for how many characters it's like away from the where it originally was, or how many characters it was shifted, if I go ahead and give it the same thing, it gives me hello world as well. And I think for this specific example, it ignores uppercase and lowercase. So that's a really simple program, and using Python, making Python scripts like these, you could automate the process of ciphers and use different create algorithms that will allow you to create encrypted messages depending on what cipher you use. Okay, so that's just one of the programs I found. So this is also another program that's based around IP addresses. So in the top here, we have import socket. So when I showed you pip install NumPy or whatever library name, I went here and I think I'm not sure if socket is actually already installed, but we're actually able to import socket into our program with the import statement. And so we're able to use all the functions and all the features it provides from the library by stating the imports at the top of the program. So here just I have a function called whoislookup, and given a specific domain, it goes ahead and finds the domain information of that the information for the domain. And at the bottom here, we have return response as we saw. And response is just gonna be the value for the decoded message of what we sent. So lastly here, we just have print whoislookup because whoislookup returns a string for us to be able to see. So if I do go ahead and run that, whois.py, it goes ahead and prints out a whole bunch of information of the Google domain, which is what I put in here. So using libraries, we're able to incorporate a lot of different features that we don't have to write and implement ourselves. And it makes programming very simple for us to coordinate and establish. All right. Lastly, I think this one. Okay. I tried to do some other stuff, but because I'm on a Windows computer, it doesn't work very well. And so there were some issues, but I think the last one I'll show you is this packet sniffer type program that I was able to find. And so for here, we have a similar import statement with a little bit of different syntax, not too important, but we have it's very similar to the program before where we create a function, and based off of the function, we are able to manipulate different things based off the information in the library. So if we go ahead and run that, this statement here is just to tell us that this is what the code does when we run it directly on our terminal. So if name is equal to main, it's going to go ahead and print starting capture packet capture, and then it'll go ahead and run the function sniff, which will go ahead and sniff for 10 packets on our network. So let's try and run that. All right, it went ahead and started, and it returns the values for print, which is in the sort of the what we call a callback function here, but because we told it to print the packet and the packet source source IP addresses, it goes ahead and it does that for us here, and we made count is equal to 10 in our argument, so it's going to do that 10 times for this function. Okay. All right. I think so much battery. All right. I'm decent on battery, but those are the main examples that I was able to find. One of them was similar to the Packet Sniffer, which was I think it was like a sort of like a firewall app. So you were able to in, give it a text file for different IP addresses to either blacklist or whitelist, and the firewall was able to operate um, either block or allow packets based on the IP addresses that were there. So what we talked about today was very simple, basic things, but once you learn, get used to the format and the syntax and are able to make programs, you can do a lot of really cool stuff, not just in Python, but in many other programming languages as well. So if you want to be able to create really cool programs that do really cool things within not only just regular programming things, but also specifically cybersecurity applications. There's a lot of free courses and programs out there to help you with programming. And so, um, let's see. Yeah, so Odin Project, Codecademy, Free Codecamp, and Khan Academy, all different websites and sources for you to be able to program from a beginner standpoint. Odin Project is my personal favorite, but that mostly deals with web development. So not specifically programming basics, though I would say programming basics are almost fundamental and very helpful for you to be able to learn web development. It talks more about networking and how how web applications work and communicate with one another. So still very good for programming, and web development is also very popular and almost essential part within that. So if you're interested in getting more in the nitty gritty of the programmer side, these websites will help you out with that. And yeah, and as always, doing your own research will help you facilitate how these concepts relate more and better together, and it'll give you a better idea of what you'd want to personally do and how you could get there and how you could grow those skills needed for the careers or topics that you might be interested in. So that's pretty much it for today's meeting. If anyone has any questions, you could go ahead and ask. We can maybe play around in Python a little bit more. So we could go ahead and do that. But overall, that's going to be pretty much it from me. So does anyone have any last comments or questions they want to ask? Yeah. I think I don't know if it'll be easy for me to share, but I do have the YouTube link for the slides here, which I will share after the meeting. And you could just check those out. I think we could just click on it. It's called, yeah, Python. What is it? Python cybersecurity for beginners. It's just a video list that I use. And I'm like, I went through it and I was like, oh, it's just pretty cool, small, simple examples that will help with what we're doing today. So I think it very much is a lot more complex than that, but some cool examples that you could play around with. So yeah, I think, and as mentioned before, like Python or programming has its specific uses in cybersecurity, but it's used in a lot of different places, like malware reverse engineering or development for security programs or programs that defend against cyber attacks or whatnot. So pretty cool stuff. All right. If any, let's see. Yeah, no problem. So thank you. I'll be on the Zoom for a bit, but other than that, you guys are pretty much free to go. Thank you guys for showing up to this workshop, and I hope I didn't bore you too much with what I had to say today. But continue learning. That's all I'll say. You may not get it on the first time, but if you keep at it, especially with programming, you will get better, and it becomes more fun too. I've been basically programming for at least 2 to 3 years, and it was very tough early on, just because there's so many things. But as a CS major, I was like, you know what, we're just gonna kind of keep through it, do what we can, go on Odin Project and go on different websites to keep learning. And I think it might differ with CIS people, but depending on what exactly you want to do and how exactly you want to implement cybersecurity or interact with cybersecurity in the career, programming could have a very important aspect with that. And I think programming also just helps you think. It creates a different uh, set of set of behaviors for yourself to be able to debug things and solve problems even quicker, and allows you to understand technology, which is applicable in other situations as well, such as systems and se se I was thinking more of like security configuration and things like that too. So, all right, thank you guys. Yeah. So I'll be here for a little bit, but if no one has any comments or questions, you guys are free to go. So I hope you guys have a good rest of your weekend, and hopefully I'll see you Tuesday on Zoom, where we'll have our next guest speaker talking with us about their journey in cybersecurity. So yeah, thank you guys. Mhm.
Have a good weekend, everybody.
You too, Matt. Thanks so much.